Welcome to the session on design patterns in Groovy. My name is Venkat Subramaniam. We're going to talk about patterns and some of the ways we can implement it in Groovy. I'm not going to use any slides here. I'm going to be writing some code examples, play with some little things that we can do in Groovy. What I would like for you to do is, of course, if you have any questions, please don't wait till the end. Anytime you have a question or comment is a great time to hear from you. If you're trying to ask a question and I'm not responding to you, that I'm not trying to ignore you at all, just that you're not in my line of sight, so just either wave at me or draw my attention. I'll be more than happy to yield to you and listen to you. So let's get started. First of course is why talk about patterns? This brings back memories. When I started programming, I was back then programming in C++ predominantly. And when Java came out and I started trying out some of the patterns in Java, it was quite exciting to see that it took a lot less effort to implement some patterns in Java compared to, for example, C++. And to a certain extent, I call Java as a post-pattern language. If you kind of look at the time when the famous Gang of Four book came out and Java came out about the same time. And then when I got into Groovy, it was about like reliving that experience. Once again, I found out it was much simpler to implement certain patterns in Groovy, relatively speaking, compared to Java itself. And so I want to share with you some of the things we can do in Groovy and how we could apply some of these techniques. Now, before I even get started with that, one of the problems with using patterns is that it is really not a great tool to design software, in my opinion. It is a great communication tool more than a design tool. So in other words, I don't think we can develop good software by just sitting down and saying, let's figure out what patterns we can use. I think that's a very poor way to approach designing software. On the other hand, when we are designing software, when we are looking at different options to consider, I think it's a great communication tool. And rather than taking many words to explain something, we could quickly say, how about using this pattern in this context? So I want patterns to emerge out of the code rather than being forced into the code itself. Now, having said that, let's talk about some patterns we could use. Now, one of the interesting things about language like Groovy is it is a dynamically typed language. And also Groovy has meta programming capability where we can extend the program at runtime by adding features. And this makes it extremely powerful to do certain things in Groovy that we cannot even imagine doing in a language like Java. And as a result, the way we would implement certain patterns in Java would be different from the way we would implement it in Groovy. And there is also a slew of patterns we could probably implement in Groovy that we can't even fathom using that in a language like Java. So we'll take a look at some of those things along the way and see how we can use it. I'm going to look at only a few patterns from the Gang of Four, but I'm going to then go on to look at a few patterns that we normally don't find in the Gang of Four. And even for the patterns I'm going to look in the Gang of Four, you will notice that we're going to implement it very differently here with a lot less code in Groovy than we would do in Java itself. So let's start with, of course, the famous pattern, the abstract factory. What's the purpose of abstract factory? Abstract factory abstracts out the creation of an object from its implementation. So we can say what object we want. Now, of course, when you're programming in C++, creating an abstract factory requires an arm and a leg. You have to write a hierarchy of classes. And we rarely do that in Java because in Java we have the class, remember? And then you can go to the class, named class, and say, give me an instance of this class, and you can work with it. So Java already makes abstract factory much simpler to implement. So would there be a reason to do it any differently in Groovy? Well, it turns out the minute you create an object in Java, how do you populate this object with data? Well, you would say, well, we could use Java beans, right? Well, unfortunately, Java Bean is a very sad story, right? Because when Java Bean was introduced, beans were excited. They said, cool, we are beans. And then they came to know that to access a bean, you would have to use those stupid getters and setters. And they were kind of in depression ever since they learned about that, right? Well, in Groovy, we can treat beans with respect they deserve. It's easy to talk to them. And if you're programming this in Java, what would you do normally? The minute you learn, you have to set properties into it. You realize that setters and getters are not really that great to use. And then you would say, could I use reflection to do this? And that kind of becomes messy. And then you say, well, I have to reach out to the comments API and then suddenly you have Commons API being used. And a lot of times in Java, the libraries and the tools are there to make up for the deficiency in the language to a certain extent. Let's see how this is going to manifest in Groovy when you want to implement it. So let's go ahead and take a look at an example here. Imagine you're developing a web application and you're going to be selling different kinds of products, a book, a CD, a t-shirt, what have you. And you realize most of the time what you have to do in your web application is receive a request, create an object, populate the object with some data that comes from the web application. That's a pretty routine thing, right? And you would notice that if you were to write this code, every piece of code exactly looks the same except for the names of the classes and the names of the property, and you realize, why are we duplicating this code over and over and over, right? And there's a principle behind this. It's called the Dri Principle. The Dri Principle stands for don't repeat yourself, and it's not just the copy and paste of code, but also duplication of effort in doing this. So let's see how we could minimize that effort here. I'm going to create a class called book here, and let's say our book simply contains a title, and I have pages, just two properties that I'm going to have in here. And I want to create a book. Of course, I want to populate the book with some data. Let's take kind of baby steps and see how we can do this. So I have a create method over here, and my create method simply says I'm going to take a class as a parameter. We'll look at other parameters in just a minute. So I'm going to create a class, and I'm going to use it. So define, I'm going to say instance equals, and how do I create an instance of a class? Well, if you're using Java, you would say, I would go to the class meta class, and I would say new instance on it. And the minute you do that, you realize you got to put a huge amount of try-catch around it, right? And the mere thought of even putting those try-catch around kind of scares you and don't want to do that. Well, in Groovy, there are no checked exceptions. So we can simply say class.newInstance and create an instance just like that, as you can see, right? So that was pretty easy to create the instance. And then I'm going to simply return that instance back to us. Let's give this a try. I want to just print out a call to create, and I'm going to send book to it. This is another thing that I really like in Groovy. In Java, you would say book.class to get a meta class of this object. You don't have to do that in Groovy, because in Groovy, the name of the class itself becomes the meta class once you create the class. So you can simply use the word book here. You don't have to say book.class over here to get access to it, right? So if I know how to get the dot there, right? You don't have to do that. So we're going to send the book, and I'm going to, once I get the object of that, I'm going to simply dump that object so we can take a look at what's in that object. And you can see that it's a book object, doesn't have a title, doesn't have the pages yet because we didn't set it. Now, where is the data that's going to come from? So I'm going to say comma, and I'm going to simply put a hash map right here. Now, why am I using a hash map? Because typically in a web application, you may get the data from a hash map as a name-value pair, and so we can simply use that very easily here. So I'm going to say title, and I'm going to use the title of one of my favorite books here, Who Moved My Cheese? And so then, of course, I could say comma pages, and let's say 96 pages. So I'm going to use this little hash map that I'm going to send to this guy and have him populate the data for us in this particular case. So how would this look like? So I'm going to say comma properties over here that I want to send to this particular object. Now, still, of course, the name and the title and the pages have not been set at this moment. How do I set those? Well, properties.each, and I can start looping through the properties, and we could say name, comma, value are the properties for this particular object. Now, this is when you say, oh gosh, now we got to set these properties, and should I use a reflection API? Should I reach out to the Commons API? We don't have to do any of those. So what do I do? I want to say instance dot. Well, of course, I cannot say name equals. That wouldn't make any sense over here, because the name of the property is not value, but the name of the property is the value within the variable called the name. So you have to say get the value of the name and then set the property with that name in the context. Well, that looks pretty daunting, but surprisingly, that's extremely trivial to do. Simply put an expression in a Groovy string, and he's more than happy to set that for you. With the minute you set the name of the property and say, that's exactly what I want to set here as a value. Let's see where I made a mistake here. He says page. Oh, pardon me, it's page, and over here, and did I call it page? Pages. So you can see how he handles the exception as well in that case. Tells you that property is not known. But notice the minute we have done this, it's able to go ahead and set the property. In this case, it tells us the book is there, the title is the title we set it to, and the page is 96. So we were able to set the values very dynamically here, and look at the fact that it took us only about a couple of lines of code to accomplish this task. So factories become extremely simple to create. For example, if I want to create another class here, for example, let's say the class I want to create here is a CD, we can see that we can use this class for other purposes as well very easily. For example, I could say there's going to be a title for the CD also, but in this case I would say volume of the CD. And we can quickly set, in this case, we can call create, and of course I would just send the CD in this case, and then when I'm done with it, I'll just dump the data for us to see. But within this, I could say title, maybe a title for this CD is nature, and then I can say the volume is going to be, let's say, volume 2, and here we are creating and dumping out the data of the CD itself. We can see nature and volume 2 came out as the response. So in other words, creating and using a factory of objects is extremely simple, and Groovy provides us a very dynamic way to access properties. And if this was not a property, if this was a method we want to call, it wouldn't look very different at all. You would simply say instance dot double quote a dollar, name of the method, double quote, parentheses, open close, invokes that method for you, or you can pass data in the parentheses as well. It's that simple to call dynamic methods as well, as much as setting properties on the object, as you can see here. So we looked at the abstract factory and how we were able to do that. Let's go a step further and look at a pluggable behavior. I'm sure we all have kind of used the strategy pattern before. But let's take an example for a minute. Imagine you're at work on a Friday afternoon and you're eager to go home or go wherever you want to go on the Friday night, right? But unfortunately, you have a task on your hand to finish, and you're pretty desperate to go home after this, right? And the task given to you is that you have a bunch of prices on your hand. So prices equals, and let's say the prices you have are 10, 20, some price values, right? And so you have these prices with you, and the task given to you is to total up all these prices. And you're saying, that shouldn't be hard, I can get that done and leave quickly from work. So you write your method called total prices. And what are you going to do? You're going to take a bunch of prices on your hand, and you're going to define a total equals 0. You're going to return the total value. So let's get this moving first of all. I'll say total prices, and send him the price values first of all. Of course, it's going to be a 0 to begin with, but we can total it really quickly. So we could say for a price in prices, and then we can simply say total plus equals the price itself. So that wasn't hard at all, right? So you got that done very quickly. But as fate may have it, before you could leave, your colleague who nags you all the time, you know who I'm talking about, comes to you and says, I need one more function from you. And you say, what do you really want? Well, I want to not only total the prices, I want to total prices over, say, $35. You say, you mean you want something like total prices over 35? And your colleague says, yes, that's exactly what I want. And you look at your watch and it's getting late already, you really want to leave, and you think about what would it take to write total prices over $35. And you stare at this code for a minute, and you realize this code does almost everything you want, isn't it? It takes the prices, it loops through it, it totals it. The only thing you have to do is skip a few values. And you kind of look at this and look at your watch, look at this, look at your watch, and then you tell yourselves, there's got to be a reason why God created copy and paste, right? So you copy and paste it really quickly, and then you say total price is over 35, and then you simply say here, if price is greater than 35, so you say, then go ahead and total, not otherwise, right? So you're basically asking him to total only prices greater than 35 and nothing else. So you got that working. But unfortunately, though, before you could call this done, your colleague catches you and says, I also need a function to total under $35. Now you're really desperate, you want to leave, so you look at this one more time and you tell yourselves, hey, this is almost there. All I have to do is change the greater than to less than. But you know, copying and pasting code one more time is an act of criminal negligence, right? You should never ever do that. But such morality doesn't apply on Friday nights, does it? So you copy and paste it one more time, and then you get this working really quickly, right? And this is going to be, of course, priced under $35, making all the copy and paste mistakes we normally make. And that works. And now you kind of slip out quietly because you don't want to take any more thing on this Friday night. Well, on the way home, it really hits you and you realize how terrible you have been writing this code. And the guilt eventually kicks in. You pull over to the nearest Starbucks and you quickly want to refactor this code. But unfortunately, as the luck may have it, some of your friends are hanging out right there and they take a look at this and get to know your dark side, right? And imagine what happens now. They don't return your phone calls. They don't want to hang out with you anymore. How life turns, right? Definitely we don't want to go that far, right? So how can we do this? So here's an idea. Let's go back to this and say, if I want to make small change here, and I'll simply say if true, grade, and total prices, then you can see that all those three methods were almost the same, except for what's in the if parentheses block. So we can easily extract that out. That's where the strategy really comes in. So what we're going to do here is to say comma selector, and we're going to extract that strategy out over here and say this selector is going to decide whether an object should be totaled or not. So we send the price to the selector, and the selector says yay or nay, and depending on that, we will do the totaling. Now, let's go ahead and take a look at this example here. If I go back and let's remove all of these for a minute, and I'm going to simply say total prices, and I want to total all the prices, so I'll simply say prices, comma, and this time I'll provide a code block and I simply say true, and this is going to total all the prices. As you can see, it totaled them up and displayed the result. On the other hand, if I only want to total prices less than $35, and I could simply say total prices, and in this case I can say it is less than 35, where it is really a name for this parameter that Groovy uses as a default, and we are simply passing a lambda expression to this function and becomes a lot easier to work with. Now, while this function is just fine, in Groovy we can make use of another syntax sugar. We can simply remove this from here and move this right outside of this function, for example. So the last two are really equivalent, except we have a few commas and parentheses in this particular call, and it becomes a lot easier to work with. Now, of course, this privilege, by the way, is only for the last closure or lambda expression we pass to functions, because the last one is very special. Kind of like how last children are special in families, right? I know it because I'm not one of them, I feel it. It's kind of like that, right? So it's basically the point is that you kind of treat it special by moving it outside, and you can just keep it like it's a parasite on this function, right? So you can just attach to it. So that is an example of how you can extract out the strategy, and this really becomes very simple to work with. Now, a lambda expression is being used here to extract the core behavior, and we simply let the function do the looping, and as a result, we can separate what we do with the data to how we select it, and as to separation of concern, much easier to design. And also notice how lightweight this is. We didn't have to sit there and design an interface. We didn't have to design a class. In fact, in Java, if you decide to use a strategy pattern, you would have a corporate design meeting. In Groovy, you just get it done, right? It's that simple to get that done very quickly. All right, so we looked at the pluggable behavior at the function level, but we can also do this at the class level if you're interested in. For example, what I can do here is I can create a class called equipment, and this requires a calculator for doing some calculations. So I could say calculator as just an object over here, and this guy can take a parameter of a calculator, and I can simply set the calculator here as a parameter, as you can see. Now, what I can do in this case is, if I want to do a compute method, I can call this compute method, for example, running calculation over here, and I'm going to just call the calculator and ask him to run the calculation at this time. So in the constructor, I'm passing a block of code, a lambda expression. I'm going to store that away on line number 5. And then in the compute method, I'm going to use that stored away lambda expression. Now, what I can do in the code in this case is I could say, for example, equipment EQ1, for example, equals new equipment. and I want to pass a lambda expression to this. So I'm going to put a little parentheses and say, calculation 1, for example. I want to just print that out. So we could simply call eq1.compute method, and that should go ahead and call the calculation we just created. Notice a small idiosyncrasy here. I mentioned that you could put this code block outside the parentheses. That is true most of the time. But the problem here is that you're calling the constructor, and if you move this outside, Groovy thinks you're creating an anonymous inner class and gets confused, so you have to put that in the parentheses in this particular case. But there's a way to get around this at the same time. What if I want to reuse this particular closure in my code? So I'm going to say another calculator, and this time I'm going to simply set this to equals a little code block, and I'm going to simply say here calc2, for example. So now I can create a equipment 2, for example, eq2 equals new equipment, and I can send the another calculator to it. I can even reuse this in another equipment as well. So if I say eq2.compute in this case and eq3.compute, we can see that our another calculator is being reused in this particular case of running this example. So you can see how we are reusing that calculator in these multiple calls. So Groovy makes it fairly easy not only to create lambda expressions and send them around, we can even save them and then reuse them in multiple calls that trivially without almost any effort at all. So that is an example of how we could use a pluggable behavior not only at the function level but also at the class level if we wanted to. So let's talk about iterator, and of course you may say, hey, but an iterator pattern is such a common pattern, we have known this for a long time. Absolutely true. But we've been using iterators very differently in Java, and we will have to kind of realign ourselves when we get to these languages that support lambda expressions. Let's take a look at an example. Let's say for a minute I have some names on my hand, and I'm going to say this name is Joe over here. I'm going to say Jane is a name, and I'm going to create a bunch of different names I'm going to use. Let's say Jill here, and I want to go through and loop through the names and print it. How do I loop through this? In Java, we would do this, right? Int I equals 0, I less than names.size, and usually your fingers will automatically pause here because you have to think about, is that less than or less than equals to, right? That's called self-inflicted wound, right? We programmers impose that on ourselves, and we don't have to do that, right? And this is kind of really troublesome, expression to use. We don't have to do that. But instead, what we can do is, in Java, we use the for each statement, isn't it? So we could say name in, and then names. In the case of Java, we would use a colon instead of an in to use this, whereas in Groovy, we can use the in, and then we could simply say print the name for me, and you can see how we are able to print the name. So this is the for each statement that you already know in Java. It's just that instead of using a colon, we are using a in, and instead of defining the type, we are letting Groovy to figure out the type. It's a dynamically typed language after all, right? Okay, that's great. But what if I really wanted the index? Then of course you would have to use for I equals 0 and use it that way. Well, in Groovy we don't have to do that. Let's talk about iterators. Now, under the covers, this for each, unfortunately, still uses the iterator. So in other words, if you look at the bytecode being generated, the for each is simply going to say, if iterator has next, go to the next iterator. That's like having a rude dog that won't move, right? And you keep pushing it every few feet. And you got to manage the iteration all by yourself. On the other hand, an internal iterator is a lot more powerful. An internal iterator says, I will take care of iterating, and you just tell me what you want to do for elements considered in the iteration. So this separates the way we iterate from what we do in the iteration. Let's take a look at an example here. Let's say I have a names over here, and I say names.each, and I want to just print the names. I could simply say print it like this, and we are able to use an internal iterator. Notice this is looping through the elements and printing each one of them. You say, aha, but wait a minute. What if I really wanted to print the index value along with the iteration? The for loop makes it very easy to do it, isn't it? Now, this is where the beauty of Groovy iterators come in. There are different flavors of iterator available. So we could say each with index, for example. How about that? And now we can simply say, in this case, I have an index over here and an element on my hand, and I can simply print the value of the index, by the way, and then I can print the element as well in here, and we can ask him to print the index and the element along the way. So we can use a each with index if we really care about the indexing, and only use a each if we don't care about the indexing. So this becomes quite easy. Is there a question back there? No. Okay. So basically you can use the iterator pretty easily, and then you can index through it. But iterators come in very many different flavors. What if I want to pick the first element from this collection? Well, let's talk about that for a minute. But before then, let's think about this. What if I want to get a collection of the number of characters in each name? Just think about how you would do this in Java. I won't write the code in Java, but think about this. What would you do? You would first create an empty collection, correct? And then you would loop through, and within your loop, for every element you consider, you'll get the length and you will add it to the collection. How do you feel about that code? Not so good, isn't it? Right? That doesn't feel right. But do we have to put that much effort to create this code? So notice what I'm going to do here. I'll say simply names dot collect, and it times length, because I just want to find the length of these elements in this case, isn't it? So length is the property, or the method in this case I'm going to call, and that was one shot to get all the values in this collection. So collect is basically an iterator that iterates through, but collects the response from this lambda expression and simply gives it back to us. And then we are returning that, or we can do more things with it if we really want to. But on the other hand, what if I want to find the first person with the 4-letter words in the name? So we could simply say names.find. And in this case, I say it.length is equal to, let's say, 3 or 4 in this case. And it's going to find Jane, obviously, because Jane has 4 letters in her name. So what does this do? The find method is another form of iterator, but this iterator only goes as long as the lambda expression doesn't return a true. As long as the lambda expression returns a false, it keeps marching to the next element. But the minute the lambda expression returns a true, it immediately returns the context element back to you saying, I found what you're looking for. So again, it separates your code from the looping aspect of things. Now, what if I want to find all people with 4-letter words in their name? I can simply call find all instead of calling find itself, and that makes the life a lot easier. Now, here is one more thing for you to think about. I'm sure everybody in this room has done this at least some point in their lives. You have been given a task to take a collection of data, and you've been asked to print them out with a comma-separated string, right? So let's think about this for a minute. What would you do? You would say for name in names, and then you could start with simply saying, I want to just print the name itself, right? You could start with that. But unfortunately, that doesn't have a comma in the between the values. You could try to put a comma here, and you realize that it puts a comma, but it puts a comma in the very end as well. And then you say, gosh, how do I remove that comma in the very end? And you realize to do that, you have to put a stupid if statement. Remember that day? And how did you feel about that once you had to do that? First of all, for doing that, you probably had to go back to the for I equals 0 format. And when you got that done, you felt terrible, isn't it? That's the lowest point of your career that day, right? When you wrote that code. And then you went home and you said, that is ugly code. I am going to refactor that. And you probably stayed up that night, late into the night, trying to figure out how to get rid of that stupid if, and you could never find a good way to do that. Remember that night? Very dark night, wasn't it? Well, let's see what Groovy does for us. In Groovy, you simply say print line names.join, and then you just call that method. What a cool way to do that. The day I learned about join, I cried that night, right? I mean, how could this be that simple to really remove all this complexity from code, right? And we don't have to write stupid code. It provides us a higher level of abstraction. While you're doing all of this, you are kind of curious, what is this little, collection we are dealing with? So you say names.class to examine this particular collection, and to our surprise, we have been using all along a Java util array list, right? So one of the beautiful things about Groovy is it doesn't give us a new data structure. It simply gives us the collection of the JDK, but adds these fluent methods to the JDK, so we don't have to put as much effort to use the collections we are already very familiar with. So as a result, we can use the collection we already know about, but with a greater amount of fluency in the code, as you can see right there. So we looked at some of those patterns from the Gang of Four, but let's move on to look at a couple of other problems we want to deal with. The first one I'm going to talk about here is really about fluency of APIs that we want to introduce. So let's look at an example of a common thing we have all done. Let's say we have a mailer class on our hand. And this mailer normally has what? It's got some, imagine this to be a Java code for a minute, right? It's got a to method, and in the to method, I'm going to simply print out, let's say, to. And similarly, I'm going to provide a from a subject. So here's a from method. And here I'm going to simply say from for us to see. This is going to be a subject method, and I'm going to simply say some subject I'm going to pass to this. And this could be a body method, which takes a message over here. And this could be a message I want to print. Let's call it body. And finally, I have a sending method. So it's going to say sending and do a send method. It doesn't take any parameters, but this is going to be a send. So how would we use this typically in Java? Well, the way we would use this in Java is we would say mailer equals a new mailer, right? We'd create the mailer object first. Maybe you even put a semicolon to say that this is a way it will look like in Java. And then I would say mailer dot, and then what we do here, mailer dot, and we could say to. And the to would be whatever address you want to send here. That's going to be my email address. It's going to sending it to. And I say mailer dot from. And this is going to be whatever from address. Maybe this is going to be my builder that's going to send it to me. So let's call it as builder at .com. And then finally, I have a mailer dot subject, and it's going to send me an email with a subject. I called it sub, I think, so we'll call it sub. And what does it do? Sub is going to simply send me a message of some kind, right? So this is going to say your code sucks or something like that. And finally, a mailer dot, it's going to say body, and then tells me how my code sucks that day. And mailer.send finally to send out the email itself. Now, of course, the code works. This looks very familiar to how we would write it in Java. But the point really is this code suffers from a number of problems, right? The first problem is, look at the noise in the code. We kept saying mailer dot, mailer dot, mailer dot, mailer dot so many times, and that's got total lack of fluency. The second problem is that we also don't know what to do with the mailer at the very end of this code. Can I reuse the mailer, or should I throw it away? There's no clear answer here, unfortunately, right? So can I just go on and call more functions in the mailer? Well, unfortunately, we don't know that, and the worst thing we can hear is go read the documentation, right? And we know how helpful documentation usually is. So what can we do about this? Well, even in Java, we could use method chaining, for example. So one thing I'll do here, just as an example in this case is, I will remove the body of this code. At the very end, we'll simply return the current object at this. And now we can do a cascading, actually. So we could do this in Java as well. So I'm going to remove all these guys and simply cascade it. So rather than putting a semicolon in the end, we just ask him to cascade through, and this is called a cascade design pattern. So we can kind of chain these method calls. We can do this in Java. I'm sure you've probably seen this already in things like Juice or EasyMock and tools like that. You can nicely flow through this and implement it very nicely. So that is an example of a cascade pattern, and we can do this in Java. But we're not programming in Java here. Let's see what Groovy can provide for us. So I'll remove that little feature and get back to this code, and how would we use it? So back to where we were a minute ago. So how is this going to look like? So let's go ahead and put the code back. And rather than doing this, I'm going to turn this around just a little bit. So I'm going to make the send method static first of all. So this is no longer on the object, it's going to be on the class. And to the send method, I'm going to pass as a parameter the body or a block of code as a parameter. So in other words, I want this to run within a context of the send method a few things. So we turned around the send method to be a static method, and we are sending a block of code to it. So what am I going to do within the send method? I'm going to create a mailer equals new mailer. And once I create the mailer, I'm going to say over here mailer.width, and I'm going to pass the block object to it. Now what does that really mean? That line of code says when you call a closure or a lambda expression, which is the block that's given here, run that in the context of the mailer object. That's what the width is saying. So in other words, if this block of code doesn't know certain things, it will then send it over as a delegate to the object to which it's invoked, the target object. So this becomes very convenient. Now, what does that really mean? How does it really work? To understand that, I'll take a break from this example, and we will come back to this example in just a minute. So let's go ahead and look at a little closure here. Let's say closure equals, and simply I'm going to say print hello here, and that's all I have, a little print of that, and I call the closure right here. So you can see that it just printed hello. But on the other hand, I'm going to remove that part right there, and I'm going to simply say print line to uppercase, for example. Now when I run this, it breaks because it doesn't have a clue what to uppercase is. It says, what are you talking about, right? Now, the beauty of closure is, if it doesn't know what you're talking about, it can either complain like it just did, but before it complains, it'll go look for a delegate object and say, hey delegate, do you think you can handle this? And if the delegate can handle it, then it's more than happy to use that. So what I'm going to do here is simply go to the closure and say dot delegate equals, and I'm going to say hello here for a second. Now I invoke this method, and notice how it prints hello. And the reason is, now that I've attached a delegate to the closure, it knows to go find the two uppercase in the delegate that's attached to it. So this is a very powerful mechanism we can use in Groovy code. So what I'm going to do here is to make use of that right here in the code we are working with, and that is exactly what I did by using this method called the width method. So the width method really sets the delegate of this object into that closure, so it can really use it. So now I can come and make use of this very nicely. So what am I going to do? I'm going to get rid of this mailer stuff from here, and I'm going to simply say mailer.send. I'm calling the send method. And within the send method, so I no longer have to call this send method. That's not needed anymore. And I'm going to move this code into this here. I can get rid of quite a few things here. So I can get rid of this mailer entirely from here. I can get rid of this parentheses from here also. So notice what happened to this code. It looks more like a configuration file or a data file more than anything else. And this leads us to creating something very lightweight like a DSL or a domain-specific language. And if you just show this part alone to somebody and say, what does it look like? Chances are they're going to say it looks like Groovy code, unless they're Groovy programmers, right? So they're going to say that looks like a data file or some kind of a configuration file, but notice that's executable code. So data becomes code and code becomes data in a way, and you can create that almost effortlessly here, and that introduces fluency. So in this particular pattern, what we have done is we have simply used the simple case of a delegate attached to a closure, and we are able to execute in the context. So we're using lambda expressions to create a fluent interface in this particular case, and that becomes pretty easy to work with. So as you can see, that's a very powerful mechanism that we can implement by creating these lambda expressions. Very powerful to play with lambda expressions and create fluent interfaces, if you will. The next pattern I want to talk about here is really going to tailor on the ability in Groovy to create metaprogramming. What is metaprogramming? Metaprogramming is where you can create really code at runtime on the fly. Now, there are different ways to do metaprogramming, and I want to kind of separate metaprogramming into two different ways of approaching it. And I would like to call it as method injection versus method synthesis. And method injection is good, but method synthesis is even more powerful. That's where the real power is, in my opinion. So what is this? Method injection is where you walk to a class and say, excuse me, would you like to have another method? I think this will be very convenient to have. That is method injection. Let's take a look at an example of method injection real quick. So I have a string equals, let's say, hello over here. And I want to just print this string right there. I print the string value. That's all I have done, right? But on the other hand, I want to be able to print out, let's say I meet somebody after a long time, I'm excited, and I want to shout hello to them. So you decide it'll be so cool to say shout on this like this, isn't it? Now, of course, when I try to run this, it doesn't work because shout method doesn't exist on this object. Well, it would be so cool if we can have a shout method. So Groovy metaprogramming allows method injection. Method injection is where you can walk up to a class or an object and say, it would be so cool to have this method here, take it. So this could be like an encrypt method, or in a web service, it could be a method that really, based on the flow of logic through the system, you decide to inject certain behavior into this object. So I can say string.meta class, for example, dot shout, and I can say this method is going to be simply returning to uppercase in this particular example. So notice in this case, I call the shout method right now, and it's able to implement that shout call. Now, of course, you say, wait a second, did you just add the method shout to the famous java.lang.string? Absolutely, you can take any class and add methods to it. You say, how dare you touch the Java lang string? Well, the last time I checked, we live in a free country, right? So it's our code. We can inject methods into anything we want to, right? So absolutely, we can inject methods into that. Now, this is method injection, but notice we injected the method into a class, but I'm not a big fan of doing that. I would much rather inject methods into instances rather than classes. Now, why so? The reason is injecting methods into classes pollutes all the instances within that context in the container in the JVM, the class loader in the JVM, which is not very desirable. I would much rather inject into this particular object, and that's very useful in the case of web applications where you can get a request, and through the request you have something injected. Once the request is over, that's forgotten, right? You're kind of isolating it. In the test cases, it's very useful because within the test, I can inject methods into this particular object, very easy to mock things, but it doesn't affect the other test, keeps the test isolated from each other. How do I really do that? Extremely simple. Rather than saying string.meta class, you simply say str.meta class. Now you inject it into the single object rather than polluting all the objects of this particular class. So if I were to call the shout method on another object of this class now, it wouldn't have the shout method. Only that particular object has that method. So you saw method injection at this point. But like I said, the real power comes in method synthesis. Method synthesis is where you can create methods on the fly based on certain context. An example of where method synthesis is being used very heavily is Grails, for example. And in Grails, based on the tables in the database, you can call methods dynamically on it, and it would synthesize the SQL query for you on the fly based on some convention. Another place where I use method synthesis quite heavily is when I create highly dynamic DSLs, domain-specific languages, because as I'm flowing through the DSL, my program will learn about a certain kind of input that come in, and based on that input, I can create certain behavior that can be exercised further down in the chain. In other words, this is kind of like the application of the command pattern, but with the application of metaprogramming on our hand. Let's look at an example of how we would do this. So I have a class called person, and this person is going to be having only one method right now called work. And this work method simply says print line working. That's all I'm going to put here, right? So pretty boring method. All that it does is work. Now we can call, for example, we can say Sam equals new person and create a person object, and once I get the person object, I can say sam.work over here and call this method, right? So, but what if I want to make this very dynamic? Well, I don't know what all these methods can do, So I could say sam.activities, and I could set some activities on Sam. For example, I want Sam to play football, for example, and then I want Sam to play, let's say, tennis, for example, right? So we could give capabilities to Sam on the fly and say, here are things you can actually do. Now, of course, in order to facilitate this, I'm going to write activities as a property in here. Now I want to come down to Sam and say sam.play football, for example. Let's say play tennis. And I want to call play tennis on Sam. And I want Sam to play tennis all of a sudden. Of course, this could be creating SQL queries, could be creating some other dynamic methods. But in our example, I'll just print out that Sam is playing tennis. But how do I do that? So if I run this code right now, we got an error. And the error says missing method exception, play tennis. It doesn't have a clue what play tennis is. So what do? I'm going to go back to this code and write a very special method called method missing. And this takes the name of a method and also an arguments collection also along the way. And I'm going to simply say you called, and I'm going to print the name. That's all I'm going to do here, right? I would like to call this method missing as the mother of all methods, right? It says come to mama if you don't find it. So it intercepts the call and says, I can respond to this for you. So it says you call tennis. But of course, you want to put some logic and rules here. So notice what I want to do now. I'm going to simply say if the name of the method starts with play, then consider it. Otherwise, what do I want to do? Else, I'm going to simply say here, throw new missing method exception. And the method exception is going to be for the name given to us on this particular object with this particular argument. So if I don't have this method, it's going to throw an exception for us and tell us that it doesn't know what to do. So I'll just simply return if it was supporting that method and supported, let's say supported, and otherwise it's going to throw an exception. So you can see the working was called because I have the work method. Let's get rid of that. We don't need to look at that anymore in this example. So I called the play tennis. It says you call play tennis. It didn't fail. But on the other hand, if I say sam.run, for example, that fails because there's no run method on Sam. So that part is working fine, right? But of course, I don't want to just support any method. I only want to support methods that start with the play. So notice how we are introducing some conventions or rules in the code. But I could also say, but not any method that starts with the play. Because Sam is a nice guy. He doesn't want to support play politics, for example, right? That's not a good thing to do. So he's going to support play tennis or football, but not play politics. How do you implement that? So I'm going to go back over here and say, if it starts with the play, then I will say define activity equals name.split. And it's going to split on the word play and get the first element out of it. If activities dot contains over here, and what does it contains? The activity we are interested in. Then I want to support it, and similarly I will say return supported. Otherwise, I'm going to simply say supported activity, let's say activity, and even want to print it here. And then I would simply say return supported, let's say true for a minute. So supported activity, or let's say I would like to play, right? And we can print that value right here. So when I run this now, you can see it says I would like to play tennis, but it says in the call to play politics, it ended up failing right there. So we can see how we can inject this behavior into this class, and then based on the context, we can resolve what we want to do in this particular case. Okay, that's great so far. But how do we go about utilizing this in the code to really inject this in a more efficient way? That's the next thing I want to look at. So notice what I'm going to do here. I'm going to call this play tennis a few times, and notice each of the time it takes a hit because it says you call play tennis, you call play tennis. So every time it goes to the method missing. After all, this won't be very efficient, isn't it? So when Grails was being created, Graham Rocher came up with an interesting way to avoid this overhead. He called it the Intercept, Kash, and Invoke pattern. Basically, the first time the method is called, you intercept it. Then you dynamically create the method, and then you cache the method. So from the next time onwards, you don't take a hit in calling it. So notice that in this case, every time I call the method, it goes to the method missing, and we're going to completely avoid that. Let's see how we're going to avoid it. So what I'm going to do here is, rather than simply executing that body of the code right there, let's go ahead and capture that code into a Lambda expression. So I'm going to say implementation equals, and I'm going to simply say object array is the args. I want to cache that away right here. And I'm going to say this is the activity that I'm creating right there. And I'm going to call that activity with the arguments given to me. But before I call that particular method, and I can even return whatever he returns to me, but before I call that, I'm going to cache it. But how do I cache it? So get meta method on the object, and I'm going to say on this object, I want to set this property, but the name is really the variable that contains the name of the method itself. So we use the technique we learned earlier. So I'm going to say $name equals, and then I'm going to simply set this value right here, which is the implementation that we got so far. So when I run the code this time, this is going to be get meta method on the current object, right? So on the current object, we're going to get the meta method. Oh, get meta class rather, right? So pardon me. So right there, we're going to say you call play tennis, but I'm going to basically reuse this object and not having to call this several times. So notice what happened in this case. I want to say print line, of course, when I'm printing this. So let's say print line. So now notice what happened. It is able to say you call play tennis. The interception happened the first time. It created this implementation, cached away the implementation, and now when I call play tennis the second, the third, and the fourth time, notice it never went to the method missing. It ended up using the method it already cached away. Here is another way to look at it. So notice right here, I'm going to first of all ask him sam.metaclass.methods.size, and he's going to tell me how many methods he has. He's got 18 methods in it. But after I inject the method, I ask him one more time how many methods he has got. And notice this time he's got 19 methods because one method was added by our method missing. So we synthesized the method but immediately injected it as well, so it can be very efficient for subsequent calls. So that is an example of how we can use the intercept cache and invoke pattern in metaprogramming. So we can give dynamic behavior to code, but at the same time we don't have to suffer the consequences of overhead in calling these methods. We can cache them and use them as well. And the last pattern I want to talk about here is a pattern of delegation. Now, we all have read books on object-oriented design, and what does it say? It says delegation is better than inheritance. And we should not use inheritance merely for code reuse. We should use inheritance when substitutability is really needed, meaning you want to substitute an implementation of a class into another place where a base instance is expected. Well, that's great. We all agree to it, and then we put down the books and we use inheritance. And the reason is that Java doesn't make it easy to inherit. In fact, if you're using something like a good IDE tool like IntelliJ IDEA, they give you features where you can right-click on the inheritance and you can say turn inheritance into delegation. And then in front of your eyes, you will notice it removes the inheritance and adds each of those methods and routes the call to it. But unfortunately, while that's very fancy IDE, that doesn't really stay longer, because the minute you modify the class, you add a method to it, you have to come back and add a method over here. If you delete a method from the class, you got to come and delete the method here, right? It becomes painful. Would be nice if the language can handle delegation really nicely. Let's look at an example of how we can use delegation in Groovy, because Groovy has this baked in already. But the beauty in Groovy is this is a compile time metaprogramming, not a runtime metaprogramming. So in other words, when you compile the Groovy code, the Groovy compiler will add at compile time these extra methods. So when you recompile the code, the methods would go away based on whether new methods are added or removed from the class itself. So let's look at an example. Let's say we have a worker class. And the worker class contains a method called work. And all that the work method does is simply print out, let's say, working, right? Let's also create another class here called expert over here. And this also contains a work method. So I have written the work method here. And this work method simply says, expert working. This is also another method called analyze. And this method simply says analyzing, let's say analyzing, right? So that's basically our code. Now I have a class called manager. As you would expect, this manager does nothing. And I want to simply create a manager object here. So manager equals new manager. But this manager is very smart. I'm going to say manager.work. And I'm going to call manager.analyze, or the two methods I'm going to call on this manager. But this manager is extremely smart. He simply says define over here. Actually, I'm going to define a worker equals new worker. And I also have an analyst or expert equals new expert, right? And the manager simply says, I am going to simply have a delegate over here, and I'm going to delegate everything to the worker first. If the worker cannot handle it, I will give it to the expert, right? Pretty smart manager, as you can see right here. So I run this and notice how the manager's work is calling working, and the manager's analyze is calling analyze, and it's not calling the expert's work method in this case. And the reason for this is, when you run this code, what you will notice is, at the compile time, it takes the manager class, which doesn't have any methods at this point. Go ahead, 5 more minutes, thanks. So it takes the manager class, which doesn't have any methods in this case, and it basically says, I'm going to add all the methods of worker into my class. If that method already doesn't exist, then it says I'm going to go to the expert and add all the methods of expert into my class, but only if those methods don't exist. So at that very moment, remember, the work method has been added to the manager class from the worker. So it will not bring the work method from the expert, but it brings the analyze method from the expert at this point. So you can see how it does this, but the beauty of this is purely a compile time meta programming. So if you're interested in looking at this a little further, you can do something like this. You can bring up Groovy shell, or a Groovy console rather. So if you bring up Groovy console, this is a little IDE that you can kind of type a little bit of code and play with it. But what's really exciting about Groovy Console is that it can also show you the transformation of code along the way as well. So I'm going to take this code we just wrote right here. I'm going to copy and paste that code here into Groovy Console. So we have this worker and the analyst and manager, all this code sitting here. I run this code and it tells us what the output is and goes through the compilation process. But what you can do here, ignoring that error for a minute, you can look at inspect AST and you can take a look at the abstract syntax tree, if you will. So I know what the problem here was. When it copied a bunch of things that didn't belong to the right place. Let's fix that. So here I have the manager. Right there, let's remove all this part. So there we go, I run this code, and now I go to the inspect AST, and you can look at the AST in different phases. So at the very beginning of this, I don't have much over here. If you look at this output that I show here, I've got the worker, I got the expert sitting here, and I also have the manager, right? That's all I have. As you can see at the very bottom, I have the manager class. But if I go through the AST phases and look at what was generated eventually, you would be seeing a lot more code in here. And if I scroll up to looking at the manager itself over here, you will notice that the manager class has acquired some really interesting methods over here. Notice the manager class right there, after the transformation was over, not only contains the constructor, but it's got the work method added to it. And the work method is simply calling the worker.work. Similarly, it's got an analyze method added, which has export.analyze. Go ahead, please.
So this is a Groovy state transformation, isn't it? So I wrote one of it myself, and is there any interesting feature here that I can debug that? If I do something wrong in my Groovy state transformation?
Like debugging things?
Yeah.
Well, I really don't know because I don't write code with bugs. No, the point is remember that Groovy is dynamically typed. So right off the bat, we have to do fairly decent amount of unit testing. So certainly we have to rely on more unit testing. You could use the debuggers to step through the code, but remember again, anytime we are using any language on the JVM, the JIT compiler already does a lot of transformation as well, right? So we still have those concerns, but I would say rely more on unit testing than debugging itself. That would be my answer. And then we can make sure the behavior is what we expect in that regard. So that shows us how we are able to use delegation pattern. And the beauty of this approach is if you remove a method, you're going to remove the method from here as well in the class. If you add new methods, those come into the class as well. So it's pretty much in sync with the code and becomes very effective. So we saw not only how we can use some of the patterns we are already familiar with, but with a lot more conciseness here in Groovy. But you also see that there are other patterns we could use because of the dynamic nature and meta-programming also that we have available to us in the language itself. I hope you found that useful. That's all I have. Thank you.